Hi there. Fine-tuning is the process of further training a large language model so that its behavior can be adapted to specific knowledge. And one of the very efficient ways to fine-tune is called as LoRA, L-O-R-A, which stands for low rank adaptation. So in this video, I'm going to show you on how LoRA works, as well as also show you the Python code to fine-tune a large language model using LoRA. If you like this video, please consider subscribing and liking it. One of the useful use cases of fine-tuning is to generate accurate SQL queries against a proprietary database schema whose custom tables, fields, and relationships were never seen during the pre-training. So without fine-tuning, the model is going to hallucinate. It is going to create SQL which do not have these proprietary table names and fields. However, with fine-tuning, the model learns the exact table names, the column meanings, as well as how the tables relate to each other. It also picks up the business-specific rules and naming conventions used in the organization. This means that the users can ask questions in plain English and get correct SQL in return. And one of the efficient ways to fine-tune is using LoRA. LoRA, or low-rank adaptation, freezes the pre-trained model weights and injects small trainable low-rank matrices into a specific layer. These low-rank matrices only has got the delta values, and as they are low-rank matrices, they are very fast to train. Now once they are trained, these low-rank matrices are multiplied and then added to the pre-trained model weights. So instead of updating billions of parameters, you only train small number of weights. Now this is beneficial because it drastically cuts the memory and the compute cost and trains much faster. It also avoids a phenomena called as catastrophic forgetting, since the base model stays intact. Now LoRA requires you to create a training dataset. Every row is a training example and each row is a JSON object specifying the role of the large language model, the user query, and the expected output. Now let us see a Python code on how to do fine-tuning using LoRA. We first start by importing few tools. From Hugging Face transformers, we get the auto model for casual LM to load the language model, auto tokenizer for matching tokenizer and training arguments, and trainer to handle the training loop for us. We also import the load data set to read our training data. Then we are going to add a new library called as PEFT, which stands for Parameter Efficient Fine-Tuning. From PEFT, we are going to import LoRA config to describe our adapter. We're gonna also import get PEFT model to wrap the base model with it, and task type to tell PEFT what kind of task we are training for. Next step is to choose the model, and we pick here the Mistral 7B, which is a 7 billion parameter model. With full fine-tuning, this model would need around 100 GB of GPU memory, and that is out of reach for a single consumer GPU. But with LoRA, we can fine-tune the same model on a single 24 GB card. Next is to load the base model. So we download the pre-trained model, but with FP16 precision, which is using half the memory of FP32. We also load the matching tokenizer, and at this point, every parameter is still trainable. The freezing is going to happen in the next step. Next step, which is the key step, which is to wrap the model with LoRA. So we create a LoRA config object that describes our adapter. We set the rank to 16. This means that every layer we adapt, we are going to add two small matrices. So matrix A has got a shape of input multiplied by 16, and matrix B has got shape of 16 multiplied by output. Their product is going to give us the weight update. We set the LoRA alpha to 32, and this is a scaling factor. The effective formula at inference time is going to be W plus alpha over R times B times A. With alpha over R equal to 2, it controls on how strongly the adapter is going to influence the output. We add a small LoRA dropout of 0.05 for regularization purposes, And for target modules, we pick QProj and VProj, and these are the query and value projections inside the attention layer. Now this is the standard recipe from the original LoRA paper. We set the bias to none, meaning that we are not going to train any bias terms. And then we call this get PEFT model to wrap the model. So this freezes all the original 7 billion parameters and adds a small trainable A and B matrices alongside them. Next step is to load and tokenize the data. So we load our training data from the JSON file what we have created earlier. Each example has got a list of messages. We join the message content into one text string. We tokenize the text and cut it off at 512 tokens. And finally, we apply this step to every example in the dataset. Now, the next step is to set up the training. So we define the training settings. The model is going to train for 3 epochs. Each GPU processes 4 examples per batch. We keep the learning rate higher because the original weights are frozen and there is nothing to catastrophically forget. Only the adapters matrices are going to move, and we enable the FP16 to save the memory, and we will log the progress every 10 steps. Now we are all set to run the training. So we pass the model, the settings and the dataset to the trainer. We then call the trainer train method to start the training, and under the hood only the 4.2 million adapter parameters are going to be updated. The 7 billion base parameters are never going to change. When the trainer finishes, we save the model, but here is the cool part. We only save the adapter weights and not the full model. The output is about 16 megabytes, not 14 gigabytes. To deploy, we load the original Mistral model once and attach the adapter on the top. And at the end of training, we will get the number of parameters trained. In our case, we fine-tune a 7 billion parameter model, but just by training 8.93 million parameters, which is just 0.15% of the original pre-trained model weights. We can also observe the loss curve, which shows loss is decreasing over the course of training. So you just fine-tune a 7 billion parameter model, but with a very efficient technique called as LoRA. If you want to try this out, you can do so on my platform datajarvis.ai. You can go ahead and pick the application which is called as Fine-Tuning Lab, where you can try this out and see on how it works. If you like this video, please consider subscribing and liking it. Thank you.